For over a century, one idea has formed the bedrock of cosmology, that the universe, on the grandest of scales, is the same everywhere and in every direction. No up, no down, and no center. But what if that's wrong? What if the foundational assumption our entire cosmic model is built upon has cracks in it? What if the universe does have a core, and finding it reveals a truth about our reality we were never meant to see? To understand just how radical this question is, we first have to appreciate the idea it challenges. It's known as the cosmological principle, and it has been the single most important rule in cosmology for 100 years. It rests on two elegant pillars: homogeneity and isotropy. Homogeneity proposes that, on the larger scales, the universe is uniform. It's like a block of Swiss cheese. If you zoom in, you see holes and solid parts, but if you step back and look at the whole block, it's all just cheese. Similarly, the cosmos has galaxies and voids, but from far enough away, it's all just universe. Isotropy proposes that the universe looks the same in every direction. No matter where you point your telescope, the view is, on average, identical. Together, these ideas paint a picture of a cosmos with no special places. There is no edge and no central point to navigate by. The most common analogy is a loaf of raisin bread dough rising in an oven. Imagine you're standing on a single raisin. As the dough expands, every other raisin moves away from you. It looks like you're the center of the action. But an observer on any other raisin would see the exact same thing. There is no center inside the dough. The expansion is happening everywhere, all at once. Our universe, according to the standard model, is that expanding dough. This concept is deeply connected to the Big Bang. The Big Bang wasn't an explosion that happened at a single point in space. It was an expansion of space itself. The dough rising. The center, therefore, isn't a place you can point to. It's a moment in time. This principle is so fundamental that nearly all our calculations about the age, expansion, and fate of the cosmos are built upon it. But what if the universe isn't playing by its own rules? For years, nagging tensions and anomalies have appeared in our own data, creating cracks in the foundation of the cosmological principle. One of the most famous is the Hubble tension. Scientists have two primary methods for measuring how fast the universe is expanding. One looks at the early universe, and the other looks at the modern universe. For years, these two methods have given us two different numbers. It's like a car's speedometer saying you're going 60 miles per hour, while your GPS insists you're going 65. Both systems are supposed to be reliable, yet they disagree, hinting that something about the car, or our understanding of it, is wrong. Then there are the anomalies hiding in the most ancient light in the universe, the cosmic microwave background, or CMB. The CMB is like a vast white wall painted at the dawn of time. From a distance, it looks perfectly uniform. But when we look closer, we see faint, almost invisible brushstrokes. And weirdly, some of the largest brushstrokes seem to be aligned in a specific direction, an axis of evil that defies the random patterns we expect. Perhaps the most visceral challenge comes from the sheer size of things we found. The cosmological principle implies a theoretical size limit for any cosmic structure. Think of it like a rule that says no single wave in the ocean can be more than a mile long. Anything larger simply shouldn't have had enough time to form. Yet we've found them. Structures like the Hercules Corona Borealis Great Wall are cosmic waves that are billions of light years long. A structure this large challenges the very meaning of large scale. So what's going on here? These cracks don't mean cosmology is broken, but they force us to ask compelling what-if questions. One of the most intriguing possibilities is the void theory. Imagine you're on a raft in a very calm part of a huge lazy river. Far away on all sides, the current is much faster. From your quiet spot, it would look like everything is rushing away from you. You might think you're at the center of some great outward push when, really, you're just in a local slow patch. What if our galaxy is in a similar cosmic slow patch, a vast underdense void. This could explain why things appear to be flying away from us so fast. Another line of inquiry revisits the very geometry of the universe. We assume it's flat and infinite, but what if it's closed? Think of a character in a classic arcade game. When they walk off the right side of the screen, they reappear on the left. In a closed universe, you could travel in a perfectly straight line and, after an unimaginable amount of time, end up right back where you started, just like that video game character. Then there's the possibility that the laws of physics themselves need a revision. Some models explore whether dark energy is truly a constant, or if gravity behaves differently on cosmic scales. Each of these ideas is a potential path forward, representing the scientific method in its relentless pursuit of a model that fits all the facts. So after all this, have we found it? Is there a cosmic "you are here" sign? The answer is no, but that's because we've been asking the wrong question. The big reveal isn't finding a point on a map. It's realizing the concept of a center needs to be completely reimagined. The universe doesn't have a core in space, it may have a core in time. The story is far from over. These tensions might resolve with better data, or they could crack our models wide open, revealing a new cosmology. What do you think? Are these anomalies simply statistical noise, or are they clues to a cosmos far stranger than we ever imagined? Let me know your thoughts in the comments below. We began by seeking a center, a single point of cosmic importance. What we found instead is a more profound truth. The entire universe is a place of cosmic importance, shaped by a single, shared beginning. Science is a story of replacing one mystery with an even greater one, and our true place in the cosmos might just be the greatest mystery of all.